Hello everybody, welcome to Hesili Maths online class. Today we are going to learn the applications of integration, that is area. So in your syllabus, we are going to look at two categories of area. There is area under a curve and area between two curves. Both cases we are going to look at whether with respect to y-axis or x-axis. Case 1, we are going to find area between the curve and the x-axis. To find the area of a region bounded by the curve y equal to fx, the x-axis and the line from x equal to a and x equal to b. So, we may use the formulas, the definite integral of radius function with respect to x from point x equal to a and x equal to b. How to find the radius functions? We may use the formula as y upper minus y lower. For these cases, the y upper is the functions y equal to fx and y lower is the y equal to 0 or is the x-axis. To find the area of regions below the x-axis, we have to take note on this. We still use the formulas of definite integral of radius functions with respect to x from a to b. And to find the radius function, we must always remember use the y upper minus the y lower. For these cases, the y upper now is the y equal to 0 or is the x-axis. Okay, the y lower now is our function of y equal to fx. Case 2 is the area between the curve and the y-axis. To find the area of a region bounded by the curve x equal to fy, y-axis and the line y equal to c and y equal to d, we may apply the formula of definite integral of the radius function with respect to y. Okay, we look at the cases whereby the region at the right hand side of the y-axis. So to find the radius function, we may use the x right minus the x left. So for these cases, the f left right is the x equal to fy, whereby the x left is the x equal to 0 or is the line of y-axis. On the other hand, if the region is at the left-hand side of the y-axis, so to apply the definite integral of radius function with respect to y, so we also have to determine the radius function with the x right minus the x left. For these cases, the x right now is the x equal to 0 or y-axis, whereby the x left now is the x equal to fy. Case 3 is the area between two curves. To find the area of the regions between the curve y1, fx and the y2 is gx functions from the point x equal to a to x equal to b, whereby the y1 is above the y2. So for these cases, the y upper is y1, that is fx functions, and the y lower is y2, that is gx functions. So to find the area, we still apply the definite integral of the radius functions with respect to x. So we will have the definite integral of fx minus the gx. On the other hand, to find the area of the regions between the curve x1 equal to function fy and x2 equal to function gy from the point y equal to a to y equal to b, whereby the function x1 is greater than x2. So to find the radius for these cases, so the x1 now is the x, right? And the x2 is the x, right? So that's why we have the area as the definite integral of x1 minus x2 with respect to y. That is, we have the definite integral of xy minus the gy with respect to y from the point y equal to a to y equal to b. Students always face difficulties in remembering all these definite integral for area. Let me introduce to you how to memorize all these formulas easily by using the LEWI techniques. Recall that the area under a curve and above the x-axis can be computed by the definite integrals. Let's say we have these two curves, y equal to fx and y equal to gx, such that the fx is above the gx. Therefore, the area between these two curves from x equal to a and x equal to b is the definite integral of fx minus the gx with respect to x. How to remember these formulas easily? By using the LEWI techniques. Okay, first of all, we have to assume that the area is always equal to the definite integral of LEWI. We're doing this with 3 simple steps. Before we proceed, let me introduce to you what it means by LEWI. For your information, le is the length of rectangular and width is the width of rectangular. So, the 3 simple steps are: step 1, we draw a LEWI block, whether it's horizontally or vertically. So we are going to draw the LEWI block horizontally when we do the region about the y-axis. When we are going to draw a LEWI block vertically when we do this with respect to x-axis. Cool. So for a block, so we have the length and the width. Length and width like this. Okay, so step 2, we are going to determine the function length and width. We apply the formula of area, so it's length times width. So that's why it will help us to write the formula of area by using the definite integral. So we are going to have the length as this is the length and this is the width, and also this is the length and this is the width. Let me introduce to you through the following examples. Look at these examples. We are going to find the area of the shaded regions. Step 1, we draw the LEWI block vertically. So this is our width and this is our length. Step 2, we are going to determine the value of length and width. So for width, since the width is the difference of the value of x, so that's why we will denote it as the dx. And for the length, so we always use the y upper, so this is the y upper, subtract with the y lower. So for these cases, the y upper is fx, so this is the y upper, and the y lower is the gx. So we use the function fx minus gx. So this is our length. So make sure that we always use the upper value subtract with the lower value in order to get a positive value. So step 3, we apply into the formula of area, that is length times width. So this is why we have the formula as the definite integral of fx minus gx with respect to dx. So this is our length and this is our width. Hopefully this technique will help you to form the formula of area easily. In the following examples, I'm going to show you how I'm going to find the area under the curve by using the LEWI techniques. We look at the example A1. We're going to find the area bounded by the curve y equal to x squared and y equal to minus x squared plus 6x. So first of all, we need to draw the graph as shown in the diagram, and I denote the y equal to x squared as the y1 and the graph y equal to minus x squared plus 6x as the graph y2. Okay, so we will notice that we are going to find the area between the curve as the shaded region. Okay, so first of all, we need to find the limit. Okay, that is the two intersections point that we have to find. Okay, so we solve the equations of x squared and the minus x squared plus 6x. So you were going to get 2 points here, one is 0 and one is 3. So we are going to use this as the limit. Okay, we are going to find the area from the limit 0 to 3. Okay, so first of all, step 1, we denote the LEWI block, and the shortest length is the width and the longer is the length. Example 2. So we have to look at the area bounded by the curve y squared plus 2 equal to x and the line y equal to x minus 8. Okay, so first of all, we need to sketch the graph as shown in the diagram, and we notice that this is the area bounded by the curve. Okay, based on the graph, we notice that it is easily, if we find the y limit, the y value, to evaluate the value. So that means that we need to find the intersection point, between these two curves. Okay, so this is the point that we want to get, and we are going to get the y value. Okay, so we convert the both function, the x in the y term first, because we need to find the answer y value here, and we do the comparison and we solve it, and we are going to get the two value, which is the y equal to 3 or y equal to minus 2. So that means we already get the limit for the area here. And then the step 1 here, so we start to use the technique of LEWI. We draw the LEWI block horizontally. Okay, because why we draw the horizontally? Because we're going to use the y limits here. Okay, so now the width become the shortest side is the dy. The difference between the y value, the length now is here. So the difference between the x value. Okay, so for these cases, we know that okay, we always denote the bigger value. Okay, I denote the bigger value. So with right hand side. So this is my right. So I denote it as x2, and the other line is the x1. So I differentiate the two lines with the level of x1 and x2 here. Step 2, we are going to determine the function length and width. Since we use the block horizontally, so the width now is the dy. Okay, and the length, we always use the x right minus the x left. So for these cases, if we look at the function here, the right hand side here is the pink color line, which is the x2. So this is the right hand side, and the left is x1. Okay, if we look at the block, the black color line is the left line, which is the y square plus 2. So we put into the function, so we have the y plus 8 subtract with the y square plus 2. Okay, please make sure that you put the function of length correctly, properly. Okay, after we decide the function width and length, so we put into the formula of length times width in the integral form. Okay, this is the limit that we found previously in the step 1, so minus 2 and 3. And then we start to simplify and we start to integrate it and we evaluate by using the calculators. So we are going to manage to get the value or the answers for area correctly. I hope that LEWI techniques can help you to form the formula of area between curves easily. Hope that you like it. Thank you very much.